This is algebra. Okay, sorry about that. This is algebra 2.5. Page is 93 to 98 in your textbook. And this is a picture of a flying squirrel. How far do you think a flying squirrel could just drop? I don't know. But an object's change in position when it drops can be done through multiplication by multiplying its velocity by the time it drops. And so later on in this lesson we're going to talk about that. So the first thing I want to talk about is the closure property of a real number in multiplication. And the first fact part of that is that a product of any two real numbers is in fact a unique real number. I'll come back to this. And two real numbers are closed under multiplication. So let me give you an example. So in our first example, we have positive 3 times negative 2, which equals negative 2 plus negative 2 plus negative 2, because it's basically negative 2 3 times. And that equals negative 6. So we can see that the product of a positive number and a negative number will come out negative. Using the definition of opposites, so we have the definition of opposites here. We have negative, and then we have 3 times negative 2, which equals negative. 3 times negative 2, which equals negative, times the negative 6. And we're going to get the opposite here of the negative, which is a positive, which equals 6. Okay, so my handwriting is bad because of my cat, but I'll do this. Rules for the sign of the product of non-zero numbers. So a product is negative if it has an odd number of negative factors. Product is positive if it has an even number of negative factors. So an odd number, like 3 negative signs, is going to mean that it's negative, and if it has an even number, it's going to be a positive. Okay? So let's look at our first example here. We have negative 4 times positive 5 equals negative 20. Well, we know that we have one negative here, so we know that the product, the end result, is going to be negative because we have an odd number of negative. Here in this example we have 2 negatives, which is an even amount, and so we have a positive product. So on this one we have 1, 2, 3 negative signs. That's an odd amount, and so our product will be negative. This one is a little bit trickier because we have negative 2 to the 4th power, which means that you're going to be multiplying the negative 2 4 times, and you end up with 4 negatives, and that's an even amount, so your answer will be positive. So let's look at this. 3. Okay, that was my dog barking. I don't know if you heard it, but yeah. So we had 3 times negative 5 equals, and here my dog just ran into the room. We'll see if he starts barking. I want to know what the sign is. The answer is 15, but what's the sign that would go there? In this case, we are going to have one negative factor, which is right there, and so the answer would be negative 15. In the next example, we have negative 2 times 4 times 5, and the answer is 40, but what's the sign? And here we have again one negative factor, so that will be a negative 40 because that's an odd number. So here we have 1, 2, 3. So our answer, although it's 2 here, we know it's going to be negative because that's an odd number. I real quick want to point out just something here. If you have negative 2 to the 4th power, it would look like this. Negative 2 times negative 2 times negative 2 times negative 2. That's going to be an even number of negative signs. There's 4, and that's going to equal a positive 16. But if you had negative 2 to the fourth power written like this without the parentheses, and that gets rewritten with the parentheses around the 2 to the fourth power and the negative on the outside, which gets rewritten to negative 1 times 2 times 2 times 2 times 2. In this case, we only have one negative, and that makes that negative 16. So the properties of multiplication. The first one is the closure property, which means the product of any two real numbers is a unique real number. And in this case, A and B is a unique real number, and the example is 4 times 2 equals 8. That's all it's saying. The next property is about the order in which two numbers are multiplied does not change the product. Okay, I'm going to try to pronounce it because it always comes out wrong. But that one is AB equals BA, and the example would be 3 times negative 2 would equal negative 2 times 3. Nothing changes there. Next one is associative property. The way you group three numbers when multiplying does not change the product. AB times C equals A times BC, and the example would be if I had negative 6 parentheses here times 2 with a 3 there, that would equal, or I could rearrange it to be that, and I would have the same answer. The identity property is the product of a number and 1 is the number. For example, 1 times A equals A, so anything times itself is going to be that number. Example would be 1 times negative 4 is going to equal negative 4. It's 1 times itself. The property of 0 is the product of a number and 0 is 0. So 0 times A is 0, or 0 times negative 2 is going to be 0. The property of negative 1 is the product of a number and negative 1 is the opposite of the number. So anything times negative 1, so in this case negative 1 times A, the A turns into negative A. If you had negative 1 times negative 3, it's going to be the opposite because it's negative 1, so the opposite of negative 3 is going to be 3. It's always the opposite. Now, just to note, sort of for future reference here, is that the properties of multiplication, they're kind of, long and tedious there to go through all those. But it's not just limited to numbers. Later on in chapter 10, you're going to encounter these same properties for when you talk about polynomials and find out that the same rules apply. So this is not something that, oh, I already know it. You're going to be reusing this information throughout the rest of the course. So let's go through some examples here. It says simplify the expression. And the first one is negative 2 times negative x. And so we can figure out that the answer here is going to be 2x, but which sign? Once again, 1, 2, it's going to be, it's 1, 2, so it's even. So there's no, it's a positive there. Now the next example is a little bit more complicated, not much, but so we have 3 times negative n times negative n times negative n. So the first step in simplifying it, we have 3, and then we have negative n to the third power. And we know because there's 3 minus signs here, 1, 2, 3, that we're going to have a minus sign right there when we simplify it. But now we got to simplify it again because now we still have to solve it. And we're going to end up with 3 n to the third power. But which sign goes there? In this case, we only have one sign, so we'll have a negative there. Okay, does that make sense how you simplified it down and then down again? So the first thing, here we had negative 1 times negative a to the second power. First thing we do is write the power as a product. So we had negative 1 times negative a times negative a. Then we can simplify down to negative 1 times a to the second power. We had two negative signs, 1, 2, so there nothing goes right there because it was even number. We can continue to simplify. When we multiply this out, we can drop the 1, so we'd have negative a squared, and we get the negative a squared because it was something we had it's the property of negative 1, which means that it's going to be the opposite of this, and so that's a positive, and so it would be a negative a squared. So we can continue simplifying. We have 8 times negative 2. We know that negative t, sorry. We know that simplified that's going to be 8t, and there's 1 there, so that will be negative 8t. Negative x times negative x times negative x times negative x is going to be x to the 4th power, and that's going to be an even number of signs, and so that will remain positive there. Okay, so here we have negative 7 times negative b to the 3rd power equals, and we know the answer will be 7b to the 3rd power, but is it a positive or negative? We have 1, 2, so it will remain positive. So the next thing I want to talk about is evaluating a variable expression. So evaluate when negative 4 times negative 1 times negative 6 when x equals negative 5. So you can do it two ways. You can simplify first or you can substitute first. Let's work it out by simplifying first. So in this case we would have negative 4 times negative 1 times negative x is going to equal negative 4x. The next step then will be to put in negative 4, and then we know that what the 5 is. Put in the negative 5, and then we work it out, and it's going to be 20, and we have two negatives, so that's going to be a positive. The other way would be to substitute first. So in that case, we would have negative 4 times negative 1 times negative x equals, we rewrite it, not like that, sorry, negative 4 times negative 1 negative 5. Okay, so you see we ended up with a double negative here because we already had a negative, and then negative 5 goes there. So that's why these are parentheses right here. They're not coming out very good today, but that's what that is. We would continue working this out. We end up with negative 4 times negative 1. And then here we had a negative and a negative, so it's going to be a positive. So it's going to be times 5. And then once again we will end up with 20. Okay. So let's look at it for a sec. We want to evaluate the expression when x equals negative 2. So in our first example we have negative 9 times x times negative 2. and we know that we're going to end up with 18x. We have two negative factors, so that's a positive. So our first part, we end up with it's 18x. We still have to solve, so it would be 18 times negative 2. We replaced the x that was right here with the negative 2. And now we know that our answer is 36. We only have one negative, so we have a negative product for that example. Another example, let's try 3 times 4 times negative x. And as we simplify that down, we would have 12x. We had one negative there, so it's going to be a positive. And oh, I'm sorry, that would be that's a negative because we had one. Sorry, I wasn't thinking. So we have next, when we put in the negative 2 from the previous page, x equals negative 2, we have negative 2. We have negative 12 times negative 2, and that will be 24 there. I forgot to carry that down. And that's an even number, so that's a positive product. Let's try it with 3 times negative x to the third power. As we simplify that down, we would have, we know if we wrote this out 3 times, we'd have negative x, negative x, negative x. That's going to be 3 negatives, so our product is going to be a negative product. And in this case, it will be 3x to the third power. And then we have to bring down the negative 2, so we would have negative 3 times negative 2 to the third power. And now we would work that out. Okay, and then we end up with, in this case, answer of 24, and we had 4 negative products in this. We had one here, and then we had one negative 2, 2 negative 2, and 3 negative 2. So that's an even number, so that is a positive answer. So in another example, we have 7 times x squared times negative 5, which equals 35, and then x squared. And then we have to replace the x squared. So we end up with negative 35 times this negative 2 squared. And then we end up with 140. We had 3, when we multiply this out, we had 3 negatives. 1, 2, and 3, because it was squared, and we ended up with 140, and with 3 of them, it's a negative. I don't know why I keep saying it's positive. It's a negative. Sorry. Okay, so we're back to the flying squirrel. And the flying squirrel drops 6 feet per second. And so you're going to be asked to find the displacement, which is the change in position of the squirrel after 3.5 seconds. Told you we'd come back to the squirrel. Okay, so displacement, that's the D here. V for velocity times time equals D equals, I already told you that the velocity was negative 6, and you're going to be asked to figure out after 3.5 seconds, so that's the time here. So D equals negative 6 times 3.5. D equals then negative 21, and so you would explain that by saying the squirrel's change in position is a negative 21 feet. So the negative sign right here indicates a downward, the downward motion, which is important here. Because the downward motion is what we're trying to explain. He crashes to the ground. So you would use, if you were talking about a helicopter, you would use the same, let's say it's descending, let's hope it's not crashing. You would use the same formula, D equals the velocity times the time, that's very complicated, multiplied by the time. And if the helicopter was descending at, let's say, a negative 15 feet per second, and you wanted to know what that's going to be after 4.5 seconds, you would end up with D equals negative 67.5 feet. Again, you know that we're talking about a downward descent there because that's what we're trying to figure out. So it's a negative number right there. And your assignment is on page 96 and 98, 96 through 98, numbers 26 through 31, 38 through 40, 45, 46, 56 through 62, 66 through 68, number 70, 75 through 78, 82 through 84, and 88 through 90. Good luck.